Okay. So as part of this assignment, we're gonna have to change, remember that there's gonna be sliders, right? To change the color of here, to change the color of the shape. So somehow we're gonna have to send from from the CPU to the GPU, we're gonna have to send this information of color. And they're gonna be like, the user is going to set this with sliders, which are HTML components. And somehow we're going to have to read that from the HTML page and send that to the GPU. Because remember, our color is defined in our shader now. So I'm going to discuss this a little bit. How do you change these numbers? Basically, like, what we have to do is change these values dynamically from the web, using the web page interface. I want to use the HTML here, and this is going to be because this is part of your work, but I want to do is the shader part. I want to be able to send data from the JavaScript side to the shader, and then you will work on the HTML part. But basically, I want to somehow create a variable here in the fragment shader that is going to be used as a replacement for these three numbers. And I want to change this variable dynamically. And here, and I want to do that mainly also because I want to introduce this idea of uniform. And I'm going to call this variable u_color. Note that I use this prefixes here to match the kind of the type of the variable. So if this is a uniform, I would say u_ the variable. And because it's an attribute, I say a_ the variable. And if the variable was a varying, I would say v_ the name. This is a very common way of naming the variables in the shader. Okay, so the idea is I'm going to create this uniform variable, and similar to this a position, I want to just give, but this is a vector 3, so I'm going to take these 3 elements here, and I'm simply going to paste this variable here and say, well, I want the color to be a vector 3, so having RGB from, and I want to set that color to be this variable. Okay, simple idea. And what is a uniform? Again, a uniform is this variable that is the same for all the vertices. So if I set this to be red, all the vertices are going to have the same information. It's going to be red for everybody. It's different than attribute. Right? Attribute has one pair per vertex. In this case, we have X and Y per vertex, and this is kind of obvious, right? We need each vertex to be different. But using attribute means that each vertex, so this variable a position is going to be different for every vertex, and here is the same for every vertex. You could use, for example, attribute if you want. You could have an attribute for color if you want every vertex to have a different color. But now we want every vertex to be the same color, so we're going to do this. That's it on the shader side. But now I have to write some sort of JavaScript code to change this variable. Okay, and that's what we're going to do. And this should be, I think, the last part of this assignment, or this lab, sorry. Basically, what I want to do is, before I draw here, I'm going to let me define an array called color. And I want to say this is 0, 1, 0. So define an array for color. In your assignment, this array is going to come, it's not going to be hard-coded, it's going to come from the sliders. So we're going to have to have a slider for this element, or this is going to be the red slider, the green slider, and the blue slider. Okay. So now let's use this array to set this variable uColor. Okay. So how do we do that? We can first retrieve, we have to first retrieve the uniform uColor from the shader. And this is similar to, it's going to be similar to this function here. So we say let uColor equals to GL, but look at the line 68, we are retrieving an attribute. So if you want to retrieve an uniform, you have to say cat uniform location. But the argument is the same, gl.program, and the name is the name of the uniform you want. This is a string with u_color. Again, this string should be exactly the same as this one, because I'm retrieving that variable. Okay. Or program. Okay. So now we can set that variable. So I'm going to comment this, set the uColor uniform. And this is gl.uniform 3f. So let me talk about this. So the GL object has a family of functions that start with the name uniform. But then for every, and these functions, they are used to set uniforms. But for each type of uniform, for example, for vectors or for matrices or for integer or for floats, you're going to have a specific function. So let me show you, for example, uniform here. If I type this, let's see if I can show you the uniform 3. It's not going to autocomplete, but in this case, it's 3f because I'm passing 3 floats. So this is a vector 3, right? This is a vector 3. So I'm using 3f because I'm passing 3 numbers. And the numbers are color 0, color 1, and color 2. I think there's a similar call that is 3v as well, if I can't remember well. But then I think if you do 3v, you could pass the whole color like this. But just to make sure, I normally use this one. So uniform 3f is gonna send these 3 elements to this vector. And I think that's it.
So you want the
hold on. Okay. But someone has a microphone. Okay. Can you please mute? Okay, so this is it. So you can just set the color of the uniform. Let's see now. Let's refresh the page. And now because our color here it's green, we should see a green triangle. There you go. And see the difference? Now we are defining our color not in a hard-coded way in our fragment shader, but now we can change this in our JavaScript. So if I change this, I see the changes in the shader. Okay. So generically speaking, you could create a uniform for any data you want to send. It doesn't have to be color. You can send any information you want. It turns out here we are using for color, but you could anything you want, you can send. For example, you see that for some reason, imagine if you want to make an animation that changes the color based on time. You could have a uniform here, for example, uniform float, maybe say like time. And somehow if you have a way to measure time here or elapsed time in your main, you could send this like time in seconds here, and then you could do some sort of, let's say, animation, multiply time by color somehow and do some sort of crazy things. Or for example, you could use the cosine of time, and then you have this kind of behavior for going from -1 to 1, and then you can multiply that by your color. So you can do all sorts of crazy effects with shaders. And indeed, indeed, that's one of the major like jobs of a lot of people in graphics, which is writing shaders, especially if you are kind of a technical artist. For example, in a gaming company, your job is to take a visual effect that someone designed maybe on paper or conceptually and make that exist as a like soft piece of software. Or imagine in a game, if you're making or in a movie, if you're making a certain explosion for a scene, you have a car and then a car is exploding, that visual effect is normally implemented through a shader. Obviously, these programmers, they have high-end tools that they use, or rendering engines, and this a lot of private, like a lot of companies have their own private engines. But these guys are specialists in shaders, because for every, if you want to customize the way your visual effects look, at the end of the day, you're going to have to write shaders, and you might be able to write them in a more fancy tool, or maybe some other features or extra like visuals stuff. But here is like, at the end of the day, you have to understand how shaders work. And if you want to, just as a quick kind of side note, there is a book called Book of Shaders, and this is for more like technical artist type of book. So if you want to kind of mimic or implement different visual effects, for example, imagine this animation here of this globe, right, rotating, and we have kind of like a eclipse type of effect, and even the texture on top. And actually, I don't know if this is a texture, probably can be a noise simulation. So all of this is done with shaders. And I don't think this book is finished, but if you're interested about what you can do with shaders as an artist, or it's a very good and inspiring book for me. So here you're gonna have like common techniques in shaders. For example, how to do noise and how to use noise for simulating certain shapes or certain textures and stuff like that. And anyway, so a bunch of things. This is just a side comment that if you're interested about shaders, you should check it out. Other than that, I think that's all I had for today.